We're going to talk about triple integrals today, everybody. Triple integrals. So the way that we learn to handle double integrals, we're going to generalize the idea to triple integrals as well. I'm going to start by going over one example for you. So suppose I ask you to calculate the following triple integrals. Example. For now, we'll just focus on the integral itself, right? Evaluate the triple integral of the function given to you as x, y, z squared dv over box B, and box B as a box is the region that is defined to you as the set of all points x, y, z, such that x is bounded between 0 and 1, y is bounded between -1 and 2, and your z is bounded between 0 and 3. Very good. So we're going to calculate this triple integral. For now, we don't care what the meaning of this triple integral is. There are a lot of applications, but for now, our job in pure math is to learn how to compute this triple integral. So take a look at these boundaries. All of these are fixed boundaries, right? Fixed numbers. Fixed numbers. From what we learned in computing a double integral, you could start by writing dx, dy, or dy, dx. It doesn't matter. We have the same thing when it comes to dv. dv, or the volume element, this is its name, is denoted by dx, dy, dz. And when we have fixed numbers, we can switch in between these differentials. So we'll take a look at this. Here I have x times y times z squared. One other thing we learned was Fubini's theorem that was saying that, hey, as long as you have two functions multiplied together and their x and y's have nothing to do with each other, we can actually separate these. We could write it as f of x dx times g of y dy. You can generalize the idea to a triple integral. So here I have x times y times z squared. So eventually I can separate these into three integrals. Am I right? So perfect. Let's see. Suppose we keep the order as dx, dy, dz. This is triple integral of x, y, z squared, dx, dy, dz. X is bounded between 0 and 1. Y is bounded between -1 and 2. And z is bounded between 0 and 3. Can I change the order? Of course. You could write it as integral, triple integral, iterative integral, x, y, z squared, dy, dz, dx. Y is bounded between -1 and 2. Z is bounded between 0 and 3. And x is bounded between 0 and 1. And more combinations to give you the exact same result. It doesn't matter. And eventually remember that you can separate these because there is multiplication between these terms. This guy is equal to the integral 0 to 3 of z squared dz multiplied by integral -1 to 2 y dy multiplied by the integral 0 to 1 x dx. You could calculate each one of these separately and multiply the result. So here you have a third z cubed 0 to 3, a half y squared -1 to 2, and a half x squared 0 to 1. So here we have a 9, and here we have a half, 4 minus 1, and here we have a half, 1 minus 0, right? So here you have 9 times 3 halves times a half, 27 over 4 is the result.